We have covered Bitcoin and Ethereum from public blockchain perspective and R3 Coda from permissionless blockchain perspective. Let us now look at another permissionless protocol, the Hyperledger Fabric. Hyperledger is an umbrella of open source projects and tools which is managed by Linux Foundation, which started in December 2015 and have received contributions from IBM, Intel and SAP Ariba to support the collaborative development of blockchain-based distributed ledgers. The Hyperledger Greenhouse details the distributed ledgers or blockchain protocols, the libraries, the tool sets, and the business domain specific solutions that the consortium is developing or have developed. Let us see a brief history of the birth of Hyperledger Fabric. The idea of privacy, confidentiality, and auditability are words where implementations fit in. A few people from Digital Asset and IBM started the project called Open Blockchain or OBC in September of 2015 and completed it in December 2015, which supports all kinds of use cases. Later, in February 2016, the developers joined Linux Foundation, which maintained the Hyperledger projects. They donated the project for future maintenance under Hyperledger umbrella. Fabric became the first project under umbrella which went live and ready to deploy to applications in July 2017. Since July 2017, when version 1.0.0 was released, Fabric has got upgraded multiple times and the current version available as on February 2021 is 2.3.1. It has over 400 developers, more than 60 companies contributing apart from 100 individuals and has over 10,000 change sets. Time to do a deep dive in Hyperledger Fabric. Hyperledger Fabric is a permission blockchain framework, meaning establish decentralized trust in a network of known participants rather than an open network of anonymous participants. It is highly modular, meaning tailor the blockchain to industry needs with a pluggable architecture rather than a one-size-fits-all approach. It allows for confidential transactions. That means expose only the data you want to share to the parties you want to share it with. Basically, flexible approach to data privacy. Data isolation using channels or share private data on a need-to-know basis using private data collections. Easy to get started. Provision to program smart contracts in the languages your team works in today, instead of learning custom languages and architectures. Smart contracts can be developed in any of the Java, Go, Python, JavaScript, etc. Pluggable consensus. One can pick up any of the Kafka or Solo consensus mechanism. IBM and other organizations are trying to develop other mechanisms also for consensus to plug into Hyperledger Fabric. Open smart contract model. Flexibility to implement any desired solution model, account model or UTXO model, structured data or unstructured data, etc. Low latency of transaction finality or confirmation resulting in better network throughput. It provides support for EVM and Solidity in case of Ethereum. Designed for continuous operations including rolling upgrades and asymmetric version support. It provides governance and versioning of smart contracts. Flexible endorsement model for achieving consensus across required organizations and queryable data. Before going to each component in detail, let us see a high-level transaction flow and basic components involved. Here, when clients submit the transaction proposal through the Fabric SDK, this proposal is sent to all endorsing peers, as you can see behind me. These endorsing peers check the transaction, verifies and executes and generate the read and write sets as output. Now, this response is again sent to the client. The client collects all responses from all endorsing peers and sends them to orderer. Now, orderer sees all transactions and orders them in ascending order and form a block. This block is then sent to all committers, which checks the transaction and add a new block in their own copy of the ledger. Let us now look at the main components of Hyperledger Fabric. Fabric comprises following main components: a membership service provider or MSP for short, client, peer, and an orderer. So what is membership service provider, or as we call MSP? The membership service provider is a component that defines the rules in which identities are validated, authenticated, and allowed access to a network. The MSP manages user IDs and authenticates clients who want to join the network. This includes providing credentials for these clients to propose transactions. The MSP makes use of certificate authority, which is pluggable interface that verifies and revokes user certificates upon confirmed identity. The default interface used for the MSP is the Fabrica Certificate Authority API. However, organizations can implement an external certificate authority of their choice. As a result, a single Hyperledger Fabric network can be controlled by multiple MSPs, where each organization brings its own favorite. There are two types of MSPs: a local MSP that defines users or clients and nodes or peers or orderers. It defines who has administrative or participatory rights at that level. And the second one is channel MSP that defines administrative and participatory rights at the channel level. Clients are applications that act on behalf of a person to propose transactions on the network. The client uses a Fabric Software Development Kit or SDK in short in order to communicate with the network, to read or write the data in a Fabric blockchain and an in-state database. Even the client is issued with a certificate from the CA authority in order to make sure that a valid client has initiated the transaction over the network. Nodes is only a logical function in the sense that multiple nodes of different types can run on the same physical server. What counts is how nodes are grouped in trust domains and associated with logical entities that control them. There are three types of nodes. A client node, a client that submits an actual transaction invocation to the endorsers and broadcasts transaction proposals to ordering services. In short, clients communicate with both peers and the ordering service. Peer node. Peer node is a node that commits transactions and maintains the state and a copy of the ledger. A peer receives ordered state updates in the form of blocks from the ordering service and maintains the state and the ledger. Besides, peers can have a special endorser role. The special function of an endorsing peer occurs with respect to a particular chain code and consists in endorsing a transaction before it is committed. An ordering service node or orderer. This is a node running the communication service that implements a delivery guarantee such as atomic or total order broadcast. Now, types of peers. An endorsing peer. Endorsing peers is a special type of committing peers who have an additional role to endorse a transaction. They endorse the transaction request which comes from the client. Each endorsing peer possesses the copy of smart contract installed and a ledger. The main function of endorser is to simulate the transaction. It is executed based on the smart contract on the personal copy of the ledger and generates the read or write sets which are sent to client. Please note that during simulation, the transaction is not committed to the ledger. The committing peer. Peers who commit the block in their own copy of the blockchain are called committing peers. They receive this block from the ordering service. This block contains the list of transactions where committing peer validates each transaction and mark it as either valid or invalid and commits to the block. All transactions, either valid or invalid, are all committed to blockchain for future audit purposes. An anchor peer. As Fabric network can extend across multiple organizations, we need some peers to have